So welcome back. So in the last session, we have started with Numpy, right? And we have seen how to work with an array using Numpy. We have understood first what exactly is an array. We have understood that array is a group or a collection of similar elements. And we have seen how to create a Numpy array using the array function. And we have seen a lot of attributes present in Numpy library, that is endim. First, we talked about endim, which tells us about the dimensionality of a Numpy array, the shape, the size for identifying the number of elements, and the shape of an array. And D type, we talked about various data types present in the NumPy. And then we talked about how to slice a NumPy array and how to manipulate a NumPy array using append function, insert function, delete function, etc. Then we talked about Boolean indexing, and we have understood how to slice your data, or how to get a specific or filter your data using Boolean indexing, right? So in this part of video, we will talk about other functions available in NumPy, and we'll also deal with a multi-dimensional array. So in the last sessions, mainly we were focusing on a single dimensional array, and whatever manipulations we are doing or whatever Boolean indexing we are doing, we were trying to do it for a single dimensional array. But let's try to now focus on two-dimensional array or a three-dimensional array and just check how it works. So as we discussed in the last session, let's discuss that again, that what exactly is the difference between a one dimension and two dimension. See, in general, for example, if you take a single axis, if I take only one axis, I'm calling it as x-axis, right? So when I'm having only one axis, where I can plot a single data, something like this, maybe 1, 2, 3, 4, 5 and 6, it's a single dimension array as discussed. Whereas if you have a two axis, I mean, here I'm having only one axis, but if I'm having a two axis, like two dimensions, for example, this is one dimension and this one dimension, this is x and this is y, and I can plot a multiple data here and here respectively. So more clearly, if you have data with rows and columns, more clearly, if I talk about table-like structure or this kind of data, we call it as a two-dimension data, right? So this is how different axis works. So here we have two axes. We have x-axis and we have y-axis. You can say this as axis 0 and this is axis 1. It's your wish. Okay. So let's see how do we create that kind of two-dimension data using NumPy. Okay. So if you want to create a two-dimension data, you should use the same array function only. We can use the array function, but it is slightly different. You can see this is how a two-dimension data looks. Okay. So I'll slightly change this to make you understand. Okay. So what I'll do is I'll just take a variable called as arr2 as usual, and I'll just say numpy dot array. Here in the previous case, I would just give like this 1, 2, 3. It would become a one dimensional array, right? Where we have a single list, and in that we have a group of elements. But now what I'm doing here is I am taking a list of lists. Okay, here I'm having a single list. In that I'm taking a multiple list. This is list 1, this is list 2, this is list 3, something like that. And you can take list 4. And you can see here each list is having equal number of elements. Here I'm having 4 elements, here also I'm having 4 elements, here also I'm having 4 elements. So what happens here is each and every list inside the main list is actually a row. Okay, and every element here are the columns. Okay, so rows and columns. So if I just create this and have a look at this, this is how my array looks like a matrix. So I can say that a two-dimensional array is like a matrix itself. Okay, where we'll be having multiple rows and multiple columns. So you can see here we are having multiple rows and multiple columns. So these multiple rows and multiple columns are itself the axis. So you can say this as your one axis and this is your another axis, right? This is one axis, another axis. So in this way, we are able to identify or we are able to create a two-dimensional array with multiple axes, of course, two axes. Okay, axis 0 and axis 1. Okay, so in that way, we are creating this, and this is how you will be creating a two-dimensional array. And one more important thing is we should have same elements. So in general, guys, if in matrices also, we cannot have 3 elements in the first row and 4 elements in the second row, right? So in the same way here also, if you have 4 elements in the first row, obviously you should have 4 elements in second row and 4 elements in third row. Then only it is called a proper two-dimensional array. That is the reason I'm maintaining the same elements. What happens if I don't maintain same elements? We'll see that. Okay. So in this way, we are able to create an NumPy array using 2 dimensions. And moreover, the simpler way to identify whether it's a 2 dimension or 3 dimension or single dimension is to look at the outer square bracket. In most of the cases, this outer square brackets will be telling you how many dimension is your NumPy array. So if you're having a two square brackets here, it means that you're having a array inside an array, right? You're having a one single array, inside that you have multiple arrays. It means that you have two accesses. When you have two accesses, obviously it's a two dimension. So in this, if you are having two square brackets here, in many cases you can identify that yes, it's a two-dimensional array. Okay. However, if you want to identify programmatically, of course you have a ndim, that is n dimension attribute. So using this particular attribute, you can say yes, I'm having two dimension. And we also know about shape, right? What shape does, as we discussed in the last session, that shape will be telling us how many elements present in each axis, right? Number of elements present in each axis. So in this case also, if you just say shape, if I just say arr.shape here, it will tell us number of elements present in the x-axis. It says 3, 4. What is this 3, 4? So 3 indicates number of, obviously you might easily guess right now, number of rows, right? 1, 2, 3 rows, and 4 indicates number of columns. 1, 2, 3, 4 columns, right? But more clearly, if I want to more clearly tell, more clearly convey this, number of elements in axis 0. So axis 0 is nothing but your rows. Okay, rows is always identified as axis 0 and columns are identified as axis 1. So we have two axes here, rows and columns. Axis 0 is rows and axis 1 is columns. So number of elements in axis 0, or we can write in brackets as rows. Number of elements in rows. So you can see number of elements in rows is 3. We have 3 elements in rows, and number of elements in axis 1, that is columns. Okay, so that is what your shape tells us. Whereas in the previous case, when we are seeing shape, we were getting only 3 or 5 or 6, something like that, because we have only one dimension and we would get only of axis 0. But we are having multiple dimensions here, so we got that many dimensions here. So 1, 2, 3. 3 rows and 4 columns. Number of elements in axis 0 and axis 1. Perfect. In the same way, if I say size, see, size is slightly different. Size will be telling us the number of elements in the entire array. We discussed about this in the last session also. So in this way, here we have 12 elements, 3 into 4, 12 elements. So you'll be getting 12. Whereas shape tells us number of elements in each axis, axis 0 and axis 1. Okay, perfect. Now let me show you what happens if I don't create same elements. I mean, as I told you already that here I should have same number of elements in each row, right? That is how the matrix works. That is how an array looks, right? But if what happens if I don't have same number of elements? Let's assume that here I'm taking the same array, but I'm not giving 4 here. Okay, I'll give 1, 2, 3, 5, 6, 7, 8.5, 9, 10, 11, 12, and something like 9, 10, 12. I've just increased my number of rows. So if we just carefully look at this, and if I see this array, you can see here, it is no longer considered as an array. It is identifying as a list of data. Means array with lists, multiple lists. Okay, array with multiple lists, and the data type is object. So basically, if you have a collection of data, it will identify it as object. Okay, so so you can see here we have multiple lists in your array. That's object. So it is identifying it as a list, but not an array, because the number of elements is not matching. And if you just now look at the arr.ndim, if I just say arr.ndim, it will be one dimension. It is no longer treating it as two dimension because it is not an array right now. The internal elements is not an array. And if I just see the shape also, it will give only one single shape. That is, we have 8 lists here, 8 elements in this. That is the reason when you want to make it as a proper two-dimensional array, the number of rows, number of elements in each row should be equal. By chance, let's assume that here we don't have any element. In the first row, we don't have any element here. It is empty. Okay. Right now we can add 4, but let us assume that in the first row there is no element. I want to make it empty. So when you want to make it empty, we can also make it as nan. Basically, in NumPy, we also have an attribute called as nan here. Basically, what is nan? Nan stands for not a number. Okay. Nan stands for not a number. It represents a empty data. Okay. It represents a null value. Okay. So instead of making it blank, we cannot make it blank first thing. If you make it blank, this happens. So instead of making it blank, what we can do is we can put nan here. So you can simply say np.nan. So whenever you say np.nan, what happens is empty null value will be inserted there. It's a nan value or not a number. Okay. So in that way, you can see here your array is now perfect. Okay. And whenever you insert a nan value, by default, it will convert it as a float. So it will be a float values because 9 is of type float. Okay, so in this way you can see your numpy array is created, a two-dimensional array is created with nan value. Nan is empty, nothing, it's representing empty value. Okay, not a number. Cool. And now you just look at your end shape, it is perfect. 8 comma 4 means we have 8 rows and 4 columns. Perfect. So it is perfect. And if I say arr2 dot endim, it is perfect. We are having two-dimensional. Okay, so instead of representing a empty value, if needed, you can actually use nan. Okay, next, as usual, yes. Now let me try to do some kind of slicing using numpy array. Okay, we have seen how to slice a single dimensional array, right? So let me slice a multi-dimensional array and show you how it exactly it works. Okay, let me start with a simple example only. No need to worry about the complex example. I mean complex data. We can start with a simple example for slicing. That's the reason I'm taking this particular data back. Okay. Okay. Now let's assume that I want to slice this part of the data. Maybe I want to slice 3 and 4. Okay. 3 and 4. How do I slice it in general? If you want to slice it, you have to slice in in two ways first. First I have to slice the rows, then I have to slice the columns. Okay. So let's start with in that way. First, I'll slice the rows. So we know that 3 and 4 belongs to which row? 3 and 4 belongs to which row? First row, right? You can see first row. And in Python, indexes start from 0. So I can say it is 0th row. Okay. So first, we should identify whatever part of data which we're interested is present in which row. It is present in the 0th row. So I can say like this, ARR2 of 0. If I say ARR2 of 0, I'll be getting the 0th row. Right. This is my 0th row. If I say ARR of 1, I'll be getting the second row. And if I say ARR of 2, I'll be getting the third row. Right. Like this, I can slice your rows. Right. Now I want to slice your columns. Okay. Let us start with first row. For example, okay, this is how you'll be slicing your rows. AR of 0 will be giving your first row, second row, third row. But if you want to slice your columns, it is slightly different. If you want to slice your columns, and if you want all the rows, means for example, I want to slice the first column. First column means what? 159, right? But I want all the rows. Or I want to slice the second column, 2, 6, 10. So in that way, we should slightly do a different way. How do we do means, in particular NumPy array slicing, basically we can give like this. Rows, comma, columns. Like this. Okay. So rows, comma, columns, you can give like this. You can slice your NumPy array something like this. Now here, my goal is I want all the rows, right? So as I want all the rows, I'll do like this. Column stands for all the rows. And which column I want? I want the 0th column. So I'll just say of 0. That's it. So this particular part indicates that all rows, comma, 0th column. So you can see rows, comma, columns. So you can see right now, I'm getting the first column. You can see 159, I got the first column. Now, if I want the second column, all rows, this column indicates everything, all. Okay. So if I say colon, what happens? I'll be getting the entire array as usual. Okay. If I say colon, I'll be getting the entire array. Okay. Now I want the first column. So all rows, comma, first column. You can see 2, 6, 10. I want the second column maybe. In terms of indexing, second column. 12. In terms of indexing, third column. In terms of indexing fourth column, of course, there is no. So I'll be getting an error, index error, because I don't have any fourth column. I have up to 3 columns only in terms of indexing. So in this way, I can slice a specific rows or specific columns like this, right? So for example, if you want all the columns, I can mention all columns and first row. First row is 5, 6, 7, 8. Sorry, first row in terms of indexing, 5, 6, 7, 8, obviously. 0th row and your last row. You can also give -1. -1 indicates the last row. Last row, all columns. Okay. So in this way, we can slice here rows, comma, columns. Now, for example, what is my main goal? I want to slice 3 and 4, right? I want to slice 3 and 4. So what I can do, I can give ARR2 of. Now 3 and 4 belongs to which row? I know that it belongs to first row. I'll give 0, comma. As usual, row is perfect, 0, comma. And which column it belongs to? It belongs to, in terms of indexing, I can say second column and third column, right? In terms of indexing, second column and third column. So what I can do is, I can do like this, 2 colon 4. Because Why I am saying 2 colon 4? Because 2 is what? 2 is your second column and third is your third column, right? So obviously your upper limit will be omitted. So if I say only 3, I would get only the value called as 3, because this particular value will be omitted. But if I say 2 colon 4, I'll be getting the first row. This is your first row. And what are the columns? 2 colon 4. 2 colon 4 means 3 and 2 and 3. 2 and 3 means you'll be getting the output as 3 and 4. Okay. So in this way, we can actually slice your data. Okay. Let me show you one more example. Let's assume that I want to slice slicing is one of the important thing, guys, because when you want to do some array manipulations or something, this will be helping a lot. Okay. Now, for example, I want to slice the value called as 6 from this particular array. So how do I do that? First, I should identify which row this particular 6 belongs to. It belongs to first row as usual. And which column it belongs to? Which column it belongs to? Obviously, it belongs to the first column only, right? So it belongs to first row and first column. So I would say like this, 1 comma 1. Okay. So if I say 1 comma 1 here, what happens? You'll be getting 6 here. Okay. Let's see that. First thing, escape plus b, arr2. And if I say 1 comma 1, perfectly arr2, sorry. So you can see I'm getting 6 because it belongs to which first row and first column as usual. Next, for example, if I want to slice 12, I can also do like this, arr2. It belongs to, can I say 12 belongs to the last row? Yes, -1. It belongs to last column? Yes, -1. So 12. So like this, depending upon the row and column, you can identify the this one. And if you want to slice multiple things, for example, let's assume that I want to slice 2 and 6. I want to slice 2 and 6. How do I slice it? It's very simple. You can simply say arr2. First thing, 2 and 6 belongs to which row? Which row? It belongs to the first row and second row. First row and second row, right? So I can say 0 colon 2. So if I say 0 colon 2, I'll be getting the first row and second row, you can see. And 2 and 6 belongs to which column? First column. So comma 1. As simple as that. Okay. So which row, so once you know which row and which column it belongs to, you can actually slice like this. Okay. So let's do one more. For example, if I want to slice 8 and 12. 8 and 12. So which rows belongs to? Which rows? It belongs to, let me write here. Yeah. So 8 and 12 belongs to which row? The last, the first and second row, right? So I can say arr2 of first and second row. So first 2, 3. First and second row means 1, 2, 3, right? And which column? Last column. So -1. So I'll be getting 8 and 12. So it's very fun. So if we just go on doing this, you'll be getting so many things. For example, let's assume that I want to slice 3, 7, 11. Means more clearly 3, 7, 11 means the third column. So all rows, comma, third column means second index. So 3, 7, 11. So it's happily you can slice however you want. You can slice your data. Maybe if I want to slice 5, 6, 7. How do I slice 5, 6, 7? So it will belongs to which row? First row. And which column? 1, 2. So this is 1, this is 0, this is 1, this is 2. So 1, 2, 3. So I'll be getting, 0 to 3 because I want 0 also, right? 5, 6, 7. So in this way, you can slice your two-dimensional array in a different way, in this way. I guess if you just go for a complex example also, it will be very easy to slice your data. So you can see I've taken a various example of slicing here in this way. In this way, you can do various examples of slicing. How can you perform slicing in Numpy? Perfect. Cool. So once you're done with your slicing, this is regarding your two-dimensional array. Now let's see how do we implement a three-dimensional array. Basically, in many of the cases, guys, in many of the no, our data science, most of the cases we will be using a two-dimensional array only. Most of your data will be two-dimension format. But if you are working with images, especially color images, we'll be working with a three-dimensional array. So how do we work with a three-dimensional array? It's very simple. See, basically when I say two-dimensional array, if I talk about a two-dimensional array is the combination of multiple one-dimensional arrays, I can say, right? Two-dimensional array is a combination of multiple one-dimensional arrays. Whereas 3-dimension array is a combination of multiple 2-dimension arrays. That's it. Okay. Here you can see here in a 2-dimension array, I'm having multiple 1-dimension. There's one dimension array, second one, third one, like this. But 3-dimension is a combination of multiple 2-dimension arrays. But before that one, let me show you one more important thing, that is print options. Just have a look at this. If, for example, if your array is something like this, I've taken a random elements in this particular array. Just have a look at this. It's still a 2-dimension array only. And if I say ARR2 here, you can see here, whenever I print this particular array, what happens is it is printing in the exponential format, like e power 0, e power 1, e power 2, something like that. Okay. So it is something, it is printing in exponential, which is somewhat difficult to us to understand, right? However, the data is not changed, but the printing is something like that. Means it is printing in the e power format. Okay. It is printing, means it is taking a lot of values as it is converted into float right now, because here I'm having float values. It is converted into float. So it is printing a lot of numbers after decimal, like huge numbers after decimal. So what we can do is we can restrict this. So how can we restrict this? In Numpy, we have a function called as set print options. Okay. So to avoid this, in many cases, guys, you can see this exponential printing of Numpy whenever you're working with a huge arrays with huge float values. When you're having a huge float values and when you're having a huge arrays, these kind of things are, in most of the cases, these kind of things are possible. Okay, printing in this way. You can see actual array is something like this, 1, 2, 3, but it is printing like this, 1 point so and so, so huge values, 2 point so much, 3 point so many values, like 3.00000, so many values we're getting, nan. Then 8.5000, something like this. If you want to avoid this all printings here, and you can see your 933 is printing like this, 9.33 into e power 2, something like that. Okay, so to avoid this exponential printing, we should use set print options method. So how do we do that? Means it's very simple. You can simply say np dot set underscore print options. It's a method, set underscore print options, and here we should use a attribute called as precision. Here precision indicates how many decimals you want after, how many points you want after decimal, how many numbers you want after decimal. So I want two numbers. For example, I want to restrict it to two numbers. So you can say precision is equal to 2. If I say precision is equal to 2, what happens? It will just print only 2 points, only two numbers after decimal, and remaining all it will suppress. So suppress is equal to true means remaining all after 2, whatever we have, it will suppress. So precision is equal to true indicates that precision is equal to 2 indicates that I want the two elements after decimal, and suppress is equal to 2 indicates that to remove all the elements. So in that way, set print options will try to remove, I mean, to limit your, to restrict your decimal points after or number of points after decimal. In that way, this exponential printing will be avoided. Okay. So let's see how to do that. The moment you say np.print options, and if you just run this code, cool. So you can see you got back your array. What happened here is because of this particular function, whatever I called, you got back your array by using this particular, I mean, by restricting the number of decimal points. Okay. It is printing normally. So in this way, you can avoid this, because this is very, very important, because in many cases you'll be facing this situation. So this particular function will be helping a lot for you to avoid those kind of printings. Okay. So it is very simple. Print options, precision is equal to 2. It's your wish. You can make precision is equal to 3 also. So it will print 3 decimals after point. Okay. Cool. Now here also we can do some kind of slicing. You can explore this. You can here also have done some slicing, means I am just slicing 11, 1, 1, 3 by using this. So 2 colon. So 2 colon everything. Yeah. So you can apply this kind of things also. Means I want elements of from 2 to everything. So 2 to everything, and second column as usual. So second column, you can see from second row to everything, and obviously second column I'll be getting this part. Okay. In the same way, 1 to 3, I mean up to 3. So this particular 159, this is a 159. So I want from 0 to 3. So instead of mentioning 0, I'm just saying colon 3. Colon 3 means what happens? It starts from 0, 0, 1 and 2. So I'll be getting 0, 1, 2, and the 0th column. 0th column means 159, something like that. I'm doing slicing here. And the same way, 3 colon minus 5. So same way you're doing slicing for this particular array. You can just explore this. Okay. Now let's see how to work with a 3D array, 3-dimensional array. Okay. So as I told you already, 3-dimensional array is a combination of multiple 2-dimensional arrays. Okay, like how two-dimensional array was combination of multiple one-dimensional array. So three-dimensional array is combination of multiple two-dimensional array. So what we can do is, when we are creating a three-dimensional array, for example, let's assume that this is your array right now, and then in that I'm taking a list. In that, what I can do is I can take one two-dimensional array. Maybe I'll take this particular small two-dimensional array for now. Okay, so I'll just go back and just take this as very small two-dimensional array. Just carefully observe what I'm just doing here. So I'm taking in a variable called as ARR3 right now. Okay, and here what I'm doing here is, in this ARR3, I'm just inserting my two-dimensional array. So in a single list, I'm inserting a two-dimensional array right now, like this. So this becomes a three-dimensional array. Means in a array, we have a single dimensional array. Sorry, two-dimensional array. So it's a three-dimensional array, obviously. So here I can create a multiple three-dimensional arrays, but multiple two-dimensional arrays. But for now, I'm creating only one two-dimension. You can see in a single array, I'm having one more two-dimensional array. And if I just take this and just show you, this is how a three-dimensional looks. So you can see here I'm having three outer brackets, three outer square brackets. Means this is your two-dimensional array, and this is your one-dimensional array, and this is your entire three-dimensional array. Let me increase the number of elements. Maybe I'll include two-dimensional array. So I'll give a comma here and include one more two-dimensional array. You can see I'm including one more two-dimensional array. So I'm having two two-dimensional arrays right now. Okay, you can see this is one two-dimensional array, right? This is one two-dimensional array. Okay, yeah, perfect. This is one two-dimensional array, and this is another two-dimensional array. Right, this is one two-dimensional array, this is another two-dimensional array inside a three-dimensional array. Okay, so the combination of multiple two-dimensional arrays becomes a three-dimensional array as usual. And one more thing is, maintaining of this number of elements is very important. By chance here, if I miss an element, it will not consider as an array, it will consider as a list. You can see here, so it is considering as a list. So maintaining this number of elements is very important when you are working with this one. So when I'm having this one, you can see here. So it's a combination of multiple matrices, I can say. And if I see the shape, can anyone guess the shape of this? You can try to pause this video and guess the shape of this particular array. So shape is very simple. As I told you, shape tells us the number of elements in each dimension. Number of elements in each dimension. So without looking at the shape function or without calling the shape attribute, I can actually identify the shape. How? First thing, let's start with axis 0. Here axis 0 tells us the number of elements in the three-dimensional array. Okay, so here axis 0 tells us number of elements in three-dimensional array. So how many two-dimensional elements we have in three-dimensional array? How many two-dimensional elements we have in three-dimensional array? 2, right? This is 1. This is 1 we have. And this is one more. So we have two elements or two-dimensional array in a three-dimensional array. So it is 2 comma. So axis 0, the number of elements in axis 0 is 2. Next, number of elements in axis 1. In axis 1 means it is nothing but your rows right now. In this case, it is rows. So 2 comma, sorry, 2 comma. Now, number of elements in axis 1. So this is the number of elements in axis 1. So we have 1, 2, 3. So 2 comma, 3 comma. And number of elements in axis 0. So we have how many columns? 1, 2, 3, 4. 4 columns. So 2 comma 3 comma 4 is your shape. As simple as that. Okay. So number of elements in 3 dimensions. So we have 2 elements in 3 dimensions. Okay. Done. Number of elements in a 2 dimension. Number of elements in 2 dimension is this. You should go to this part. So we have 1, 2, 3. We have 3 elements in 2 dimensions. Number of elements in single dimension. So you should go to single dimension. Like this. I repeat once again. First, you start with like this. Number of elements in 3 dimension. So we have 2 elements, two dimensions in 3 dimensions. So 1 and 2. So 2 comma. Number of elements in 2 dimensions. So 2 dimension means this. Any 2 dimension you can go. This is my 2 dimension, right? So how many elements we have? 1, 2 and 3. So 2 comma 3 comma. So 2 into 3 is 6. So you have totally 6 elements here, right? So 2 into 3, 6. So 2 comma 3 comma. And number of elements in single dimension. So single dimension is this 4. Like this. So 2 comma 3 comma 4 is your shape. So if I just say shape also, you'll be getting the exact same value, 2 comma 3 comma 4. So 2 elements in a main dimension, that is axis 0, 3 elements in axis 1, 4 elements in axis 2. We have 2 or 3 axes here, axis 0, axis 1, axis 2. It is something like this. If I talk about in the graph, you might already guess it right now. So you're having one axis, right? You're having one axis, something like this. Sorry. We're having one axis something like this, second axis, and obviously you have a third axis also. You can say it is x, this is y, and this is z. Okay. So in this way, we're having three axes. That is nothing but your three-dimensional array. Something like this is. Okay. So number of elements in axis 0 is how much? Axis 0, we have two elements. Okay. And axis 1, we have three elements, sorry. And axis 2, we have four elements. So in this way, we should identify the number of elements present in the each dimension. Okay. Each axis. Okay. Perfect. Next. Now, how do we slice it? Okay, so if you want to just check with the multiple elements also, we can check here. I've taken a multiple elements of an array here, same way, and you can just check here. You have a, you can see, now can anyone guess the shape? We can just pause this video and try to guess the shape of this. So we just see this particular array right now. Here we have three two-dimensional. It's clear that we have three two-dimensional arrays. 1, 2, and 3. We have three two-dimensional arrays. So the shape will be 3, comma. Now we will go to single two-dimensional array. So you have to go to two-dimensional array. So in two-dimensional array, how many elements we have? 1, 2, 3. So 3, 3, and 1, 2, 3, 4, 5. We have 5 elements in the single dimension. 3, 3, 5 will be the shape. So we just go back. Yes, 3, 3, 5 will be shape. So 3 elements in axis 0. Then if I go to axis 1, this is your axis 1. Axis 1 we have, or you can go to this also. Always it will maintain the same elements. It should maintain the same elements. Axis 1. Any axis 1 you can go. So axis 1, how many elements we have? How many rows we have? 1, 2, 3 rows we have. How many columns we have? 4 columns we have. So 5 columns we have. So 3, 3, 5. So in that way we can identify the shape. Perfect. Cool. Next, we have size. Size tells us, as usual, it tells us the number of elements in the entire array. So it is 3 into 3 into 5. It is obviously 45. So in this way, we can say what is the how many number of elements we have in the entire array. Okay, as simple as that. Next, we have how to slice your array right now. So right now we have seen how to slice a two-dimensional array, right? So the same way we can slice a three-dimensional array. How? See, the only difference is here extra dimension is added. So when your extra dimension is added, extra value will be added in the when you want to slice. Okay, let me take a simple example. Now, for example, if you want to slice 8 and 4 here, okay, this part I want to slice. Let's assume that I want to slice this part. The very first thing you should understand is this 8 and 4 belongs to which element of a three-dimensional array. First, you start with three-dimensional array slicing, right? So which element of three-dimensional array? So this is your zeroth element of three-dimensional array. This is your one element of three-dimensional array. This is second element of three-dimensional array. So I can clearly say that 8 and 4, whatever I want to slice right now, belongs to the first element. Okay, first element of a three-dimensional array. So how do I slice that right now? It is very simple. So I can say first I'll start with ARR3. If I say 0, I'll be getting the zeroth element. This is my zeroth element. If I say 1, I'll be getting the first element. This is my first element. Okay. If I say 2, I will be getting the second element, like this. So as I want to slice the first element, I can say AR of 1. I'll be getting the first element. Okay. Now once you got this, you know how to slice 8 and 4 right now, because again it's a two-dimensional right now. So when you slice your three-dimensional array, obviously you'll be getting a two-dimensional array right now. Now how to slice? You know how to slice 8 and 4? Yes, you know that. It is very simple. You should identify 8 and 4 belongs to which columns and which rows. So right now 8 and 4 belongs to your first row. I mean in terms of indexing, first row. So 1, again 1 comma 1 comma. Which column it belongs to? Which columns? Last two columns. Means it's clearly in this case it is 0, 1, 2 and 3 and 4. 3 and 4 means 3 to 5 we can say. 3 to 5. Cool. I got 8 comma 4. So it is very simple. We should start with first three-dimensional slicing. And then we can proceed with that. For example, let's assume that I want 9, 10 and 11 of this, or maybe 90 to 120, 90 to 120, 121, something like this. Then what I should do? I should see 90 to 120 and 121 belongs to which element of three dimension? Obviously the last element. So I can simply do -1. Okay. I can simply do -1. Okay. Comma. If I do -1, I would get this 90 to 120, 121. Right. Now how to slice 90 to this particular part? It's very simple. Again, it belongs to which column? Sorry, which row? Last row again. Which column? Which column? 0 to I can say up to 3. So I'll be getting 90 to 120 this one. So it's very simple to slice a 3-dimensional array also once you know how to slice it. Obviously, if you do ndim for n-dimensional array, it becomes 3, right? So in this way, you can slice a 3-dimensional array also. The only thing is, the only funda is you should start with a 3-dimensional array slicing. Once you know your slicing part is present in the which element of 3 dimension, it will be very easy to you. So in this way, a 3-dimensional array works. Okay. Now let's see some more functions of a NumPy array. Let's start with one more simple and one more important function, that is flatten. Okay. Let me open my notes. Cool. Now what flatten does actually? Let me explain you. So we have multiple other functions. Let's start with one important function that is called as flatten. So what flatten does means it converts any multi-dimensional array, okay, any multiple dimension array to single dimension. It converts any multi-dimension array to a single dimension or one dimension, I can say. So I can clearly say, as the name says, flatten, just flatten into one, just flatten, just make it to one. That's the main idea behind the flatten function. Okay. Let's see a small example here. Let's see a small example of how flatten works. Okay. Let's assume that here we have an array like this, which is a 3-dimension array. Okay. You can see it's a 3-dimension array. Already ARR3 is a 3-dimension array, right? It is 3-dimension array. If you just have a look at this. All right. Now, if I just say flatten here, if I say ARR3.flatten, it converts your entire array into a single dimension. You can see we have 1, 2, 3, 4, 5, 6. You can see entire array is converted into a single dimension. That's the main idea behind flatten. So flatten majorly converts your entire array into 3-dimension array. Okay, perfect. In flatten function also, basically in flatten function also, we have a attribute called as order. Okay, order, and by default the order is C. Okay, by default the order is C. It is by default, means you don't need to give that particular order. It's a default argument, I can say. Order is C. But what are the other orders available, and what exactly is C in general? So if we just click on this, and if we just see, these are the major orders available. So C stands for row major, and we also have something called as F. F stands for column major, and we also have A and K. You can just see that what is A and K. So what is row major and column major means? See, if I just say, for example, order C, it will mainly flatten in a row wise. Okay, you can see it is mainly flattening in row wise. You can see you're getting 1, 2, 3, 4, 4 first, then 5, 6, 7, 8, 4, right? You're getting 5, 6, 7, 8, 4 first, then you're getting 9, 10, 11, 12, 14, right? Then you're getting next row, that is your 4, 1, 2, like 1, 2, 3, 4, 4, then 5, 6. It's like row wise. But if I make order F, let's see what happens. If I make order as F instead of C, if I make it as F, it is actually doing column wise. So you can see I'm getting 1, then you're getting 1, then you're getting 221, then 5, where is this 5, then 5, 5, 52, then 9, 9, 92, 2. So it is depends. So how do you want to order your data? When you're flattening your data, you want to go with row major, column major, or we also have another orders that I will be leaving as a task to explore. That is A and K. So you can just explore what exactly is A and K. So depending upon your requirement, you can actually order your data in a flatten method. So what is main idea behind flatten? The main idea behind flatten is to convert a multi-dimensional to single dimension. It might be 3 to 2. Right now you're converting a 3-dimension to 2-dimension. All right. So which order you want to do it, that's your wish. Okay, perfect. Now when you do flatten here, and if you just look at your ARR3, your ARR3 will be as it is, because your array is not updated right now. It is as it is right now. You can see, even though you applied flatten method, it will return the output, but your ARR3 is as it is right now. If you want to update your ARR3, I mean, if I say ARR3.ending, it is still a 3-dimensional array right now. It is not updated. So if you want to update your ARR3, for sure you should do like this. You should say ARR3 equal to ARR3.flatten. So when you do like this, what happens is whatever output, whatever one dimensional array we have, that will be returned and saved in this particular variable. Okay. Now if you just look at your ARR3, you can see ARR3 got updated, and if you say ARR3 dot size, it is 45, and if I say ARR3 dot shape, yeah, it is 113, sorry, ARR3 dot shape, it is a 45 elements with one single data. Okay. And if I say endim, it is a single dimensional. So in this way, you can convert a multi-dimension to single dimension, not only two dimension, not only three dimension. For example, if I'm having ARR2, so ARR2 is a two-dimensional array, you can see right now. If I say dot flatten here, if I call flatten, it converts into a single dimensional array, something like this. Okay, like this you can do. Perfect. So flatten converts a multi-dimension to a single dimension as usual. But if you want to convert maybe 1 to 2 dimension, or 2 to 3 dimension, or 3 to 2 dimension, something like that, means one particular dimension to other particular dimension, and or else you want to change the shape of your array, means you have a shape of an array, if you want to change it, then we can use reshape. Okay, we can use reshape. So what reshape does is, it will change the shape obviously, and it will be helping us to convert dimensions also. Okay, if you want to convert one particular dimension to other dimension, we can use reshape. To other dimension, we can use reshape, and also to change the shape of a numpy array depending upon the number of elements. Change the shape of numpy array. Okay, so it will be helping in two cases. Okay, so let's see how can we implement this reshape function. It's very simple. First thing, in order to implement a reshape function, you should identify the size of an array, because based on the number of size only, we can actually give a proper shape. Okay, so if I say ARR size, right now it is 45, right now the ARR3 dot size is 45, and if I just look at your ARR3, it is right now, it's a single dimension, because by using flatten function, I'm converted to single dimension. What if I want to convert this into a two dimension? If I want to convert this into two dimension, I should use like this: ARR3 dot reshape. I should use a function called as reshape, and here in this reshape, I should give a new function, and as I want to convert into a two dimension, I should give a two dimension shape. So what would be the best way to convert this into two dimension? So what is the factors of maybe two factors of 45 I should find out. Okay, so maybe what was the best one? Okay, maybe I can say 9 into 5, I can try 9 5, I can say. So if I can give 9 comma 5, this 9 comma 5, so this is very important, guys, to maintain that shape. Okay, if I give 9 comma 5, what happens? I'll be getting 9 rows and 5 columns. Okay, you can see the same array, whatever I'm having, it is right now converted into a two dimensional array right now, you can see, and you're having 9 comma 5, or you can also make it 5 comma 9, it's your wish. You'll be getting 5 rows and 9 columns like this. Okay, so this is nothing but you're converting a multi-dimensional array, I mean sorry, single dimensional to multiple dimension. Okay, means you're converting a two dimension, right? Okay, and here also you have column measure and row measure. Here also you're having order, so depending upon your requirement, you can do. By default the order is C, but you can make it F, and you can convert in that way. It's your wish. Ultimately, how do you want to convert is our requirement. Okay, most of the cases we go for column measure, order C itself, that is your row measure itself. Okay, in the most of the cases we go for order C. Order C will be helping us in many cases. Okay, now for example, I want to convert in a different shape. You can do that. You can try in a different shape. We can see the factors of 49, 45 and C. Now if I want to update my array right now, so array of 3 is still a single dimension. If I want to update, you can update like this. So ARR3 is equal to ARR3 or tree shape, and if I say ARR3 dot shape right now, if I say ARR3 dot shape, it is 5 comma 9 right now, and you can see the ARR3, it is right now a two dimensional array. But what if I want to convert this again to three dimension, means 2 to 3 dimension? Okay, 2 to 3 dimension. Then again, what I should do? I should do like this. So ARR3 dot reshape. So what is the three dimension? I can say 3 comma 3 comma 5. I can try. Yes, the actual dimension what was there. So 3 comma 3 comma 5 I can try. Okay, perfect. So I can say I got my original array back, right? I got my original array because I have converted this array into one dimension, then I have converted two dimension. Now I'm converting into three dimension, right? So you can see I'm converting a two dimension to three dimension by using reshape, and now I have to update my array. Okay, and if I just do arr3 dot size, it is as usual 45, and shape it is um, 3 comma 3 comma 5. Okay, like this I'm converting into a three dimension array. Okay, by chance if I don't give a proper number of elements, maybe instead of 5 if I give 6 here, okay, instead of 5 if I give 6 by chance, I would get an error saying that they cannot reshape 45 into 3 comma 3 comma 6, means the number of elements is not matching with the shape. That is what it says. Okay, so always the number of elements should match with your shape. In that case only this reshape function works. Okay, in the same way, for example, let's assume that I'm having arr2 here, and here I'm having some number of elements. If I say arr2 dot size, it's approximately 24. And if you want to convert it three dimension, means it's a two dimensional, right? It's a two dimension. If you want to convert it three dimension, you can use like this 4 comma 4 comma 4 comma 3 comma 2. Right now, if I just look at the size shape here, it is something like this 6 comma 4. But what I'm doing here, I'm splitting this 6 into 3 and 2. So something like this, I'm doing 4 comma 4 comma 3 comma 2. So you can see it is converted into three dimensions. So 2 to 3 dimensions, something like that. So in that way, you can use reshape to change your shape of a numpy array. Or if you want to convert one particular dimension to other dimension also, you can use reshape. So flatten and reshape will be using a lot in numpy manipulations. Perfect. Next. The next function which we are exploring is arrange. Arrange. As I told already, guys, here in the previous session, I told you that when you want to create a numpy array, we can use this many functions to create a numpy array. Already we have used array to create a numpy array. Now let's talk about arrange. Okay, let's discuss about arrange. So before talking about arrange, guys, I guess you people might remember a function called as range. If you remember, there was a function called as range which we discussed in for loop. So what range function does? It will create a range of values between a minimum to maximum value, right? So if you just explore, if you have just seen range, let me first show range how exactly it looks. So I'm just converting to list to see it. So range of, I would give the minimum value. So for example, minimum value is 5 and maximum value is 15. So I would get the list of elements between 15 to 5 to 15, means upper limit will be omitted. So I'll be getting 5 to 14, and the step size was 1. The third argument was step size. If I give 2, I would get this, right? What was the disadvantage of range? The main disadvantage of range was it would not accept float values. Means if I want, here 2 stands for the two spacing, right? Means the spacing between the elements. So 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11, something like that. But if I want the float spacing, I want 2.1 as my spacing. It was not working because range was accepting only integers. So range will be exactly working like range only. Exact working of range is range. But the main difference and main advantage of range is it accepts float values. Okay, let's see. So how range works is it creates an numpy array of range of values. So I can give like this np dot range of 10 comma 1 comma 10 maybe. And if I, by default here also the step size is 1, means if I don't give any value here, so from minimum to maximum value it creates elements of list of array of elements, and in that the spacing of elements is 1. So you can say 0, 1 minus 0 is 1, 2 minus 1 is 1 by default. But here I can change my step size. I can make it 2. So you can see the spacing between the elements is 2 right now. So 2 minus 0 is 2, 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2. Here the advantage I told you already, it accepts float values. Means for example, I want 2.2 spacing, it can do. So you can see the spacing between the elements is right now 2.2. Okay, this is not possible in range. Okay, not only the spacing, but for example, if I want to give a float values for your ranges also, minimum and maximum value you can do. Means I want elements between 2.5 to 10.10, something like that, and with 2 or with 2.56 as spacing, something like this it will do for us. Okay, so between 2.5 to 7 between 2.5 to 10.10 or 2.5 to maybe I'll say 20.5. okay, I'll be getting the elements with 2.56 spacing. So I can use any floating value to use this. So this is a minimum value, this is a maximum value, and there is spacing between the elements. So the spacing between the elements will be always 2.56 here. You can see 5.06 minus 2.5 is 2.56. 7.62 minus 5.06 is 2.56. 10.18 minus 7.62 is 2.56. So like this, the spacing between elements will be always 2.56 like this. Okay. These are the A range works. Okay. Next. So we can use the same A range in for loop also. We can say for I in A range of some random ranges I'm giving, and it will iterate. Or I can give this particular range also. It will iterate. So instead of range, for example, in some cases you want the floating point, then you can use A range instead of range of your number. You can see you are getting this. So here you can see it is printing only two values here after decimal, because if you remember, we have used suppress option, right? And we are suppressing it to two decimals. That is the reason it is printing two decimals. Whereas when it is printing as actual number but not numpy array, you can see it is printing a huge decimal values, right? Cool. So this is how the A range function works. This is how the A range function works. The next function what we have is linspace. Okay, linspace. So what is linspace actually? So linspace is, here in linspace also I have to give three elements. Okay, three elements, the minimum value, the maximum value as usual, like A range. But here the third element is not the spacing between the elements. The third element is the number of elements we want in the array. Number of equally spaced elements we want in the array. For example, I'll say that from 0 to 10, I want 5 elements. So you can see from 0 to 10, I'll be getting 5 elements. You can see 1, 2, 3, 4, 5 elements I'm having. For example, if I say from 0 to 10, I want 4 elements. I'll be getting only 4 elements. And they're equally spaced. If you just say 3.3 minus 0, it will be 3.33. And if I say 6.66 minus 3.33, it will be obviously 3.33. And if I say 10 minus 6.66, it will be 3.33. So here you are getting the equally spaced elements, and we are getting 4 equally spaced elements. Okay. So here the third, so the first and second attribute is same like A range only, the minimum and maximum value. But the third argument here is in linspace. The third argument is your number of equally spaced elements. Let me show another example, then you'll be getting some more clarity. For example, if I say like this, np.linspace of maybe 5 to 30, 5 comma 30, and between 5 and 30, maybe I want only 5 elements. Okay. So you can see between 5 and 30, I'll be getting only 5 elements. Here you can see 1, 2, 3, 4, 5. And here the thing is, the upper limit is also included. Okay. In A range, the upper limit was not included here, but here the upper limit is included here. Means the maximum value is also included. You can see 30 is included. Okay. And you can see you're getting 5 equally spaced elements between 5 and 30, and all are equally spaced as usual. Okay. Or between 5 and 100, I want only 5. 5 and 100, I'll say 5 and 100, I want only 5 elements. Okay. So you can see between 5 and 100, I'm getting 5 equally spaced elements. I want 10 equally spaced elements between 5 and 100. I can say like this, 10 equally spaced elements between 5 and 100. Okay. This is mostly used in linspace, is mostly used in histogram, guys, and also other functions. We'll see that in the practical use case of linspace, where exactly we'll be using that. Okay, this is how linspace works. Now you can see one more example here. Between 0 to 10, I'm generating 10 elements. You can see 10 equally spaced elements between 0 to 10. Okay. Now see, when you talk about A range, if I don't provide the last element, like the last the third argument, step size, that is, the default would be 1, right? I mean, I would get the 1 equally spaced elements. But here, I mean, the equally spaced the spacing between the elements would be 1, or step size would be 1. But in linspace, what is the last attribute? 50. Okay, the last the last argument default value is 50. Means if you don't mention the last value, that is a number of elements, it is 50. Okay. So if I say between 10 and 30, and if I don't give any values, you can see I'm getting a 50 equally spaced elements. The number of elements is right now 50. So if I just say length of, you can do like this, length of this, it will be exactly 50. The length of the array is 50. You can see 10, 50 equally spaced elements. You can see, and if you just calculate the spacing between the elements here, it will be always equal. So like this, your linspace works. So the main idea behind linspace is, from minimum to maximum value, you can create a equally spaced elements. Okay, and let me check whether your float value is working or not here. Yes, float values also work. Obviously, the number of elements float value will not work because we cannot have 10.1 equally spaced element, right? It will round off. Okay. So always the last number should be a integer because number of elements means what? Number. It's a integer, not a float. We cannot have 10.1 elements. Okay. So it will round off to 10. Okay. So in that way, you can use the linspace. Okay. Perfect. Next. The next function we are exploring is, okay, I will be giving this log space as a task to you. You can explore this log space. Okay, log space is a task for you. Okay, your linspace is what? Your linspace is mainly focusing on the equally spaced elements. Here it will be focusing on logarithmic of space. Okay, just try to explore that. The next function we have is zeros. Okay, the next function whatever we have in NumPy is zeros. So what is zeros means? If you want to create an array of zeros, all completely zeros, you can use zeros function, as simple as that. Okay, so what we can do is we can simply say np.zeros, and in this I have to give the shape. So if I give 3 comma 3 here, it will create elements of 3 by 3. Okay, so you can see, or if, for example, if I give 10 comma 10 by chance. Okay, so it will create a huge array of 10 by 10 of completely zeros. This will be helping us to, for example, if you want to add zeros to your existing NumPy array, or in especially in your image manipulations, you will be having a concept called as padding, where you want to add some outer image, outer what we call outer layer to a, or outer padded to your existing image. You can use zeros function like that. You can use zeros for multiple things. Zeros is mainly for creating elements of zeros, and mainly you can use it for adding or doing some manipulations to your data. Okay, and the shape is your wish. Maybe I want 3 comma 2, the elements of 3 comma 2. You can see you're getting zeros of 3 comma 2. In the same way, we have once, one more function called as once. What once does is, it will, the same way it works as zeros, but the only thing is it will create a elements of all ones but not zeros. Okay, so it's something like this. For example, you are working with images, and if you want to add all the black pixels, you can use zeros. If you want to add a white pixels, you can use ones, something like this. If your pixels are like converted into zeros and ones by chance. Okay, uh, 3 comma 3, for example, if I 3 comma 2, it will be creating a 3 by 2 shape of ones. Okay, cool. And the next function we have is I. Here I stands for identity matrix. Identity matrix, I guess you know what is an identity matrix, right? Yes. So the elements, if the diagonal elements are 1 and remaining all are 0, that is an identity matrix. So if I say np.I of 3, and if you see all the diagonal elements are 1, so it's an identity matrix. Or for example, if I give 5 comma 5, you're getting all the elements of diagonal elements as 1 and remaining all are 0. That's an identity matrix. Okay. Next, the next function we have is random.rand. Random.rand. So random.rand, as the name says, it will generate random elements between a particular range. For example, I want a NumPy array of a random elements of a particular shape. You can use this random.rand int. For example, let's assume that from 0 to 10, there's a minimum value and maximum value. Okay, there's a minimum value, there's a low value and high value. So from 0 to 10, this is a range of the random values I want. I want a array of element 2 by 3. So you can see here, it will create an element only between 0 to 10 only, and the shape is this 2 by 3. Let us assume that I want elements from 0 to 100. Random elements, any randomly it will choose between 0 to 100 of this shape. So you can see random elements of this particular shape. I want to change my shape, maybe I'll just say 5 comma 5. More number of elements will be getting, more number of random elements. Again, you can see all the elements are less than 100 and more than 0. Or you can give negative values also, maybe 50 to minus 50 to 100, maybe minus 10 to 100. You can see some negative values also, because I'm giving minus 10 to 100. So the range is your wish. Between minimum value to maximum value, it will generate a random elements of that particular shape. It is also used a lot when you are working with some randomizations of your data. Okay, cool. So let's do some kind of arithmetic operations using NumPy array. So let's assume that I'm taking two random arrays right now. So A is one random array right now with some elements in this, and B is one more random array with some elements in this. And you can see both are two-dimensional arrays. And if we just look at the shape of these two arrays, the two arrays shape is exactly same. Now let me try to do some arithmetic operations. Maybe first let me try to add. So I'll just do A plus B. So if I just do a plus b, what happens? Each element of this first array will be added to second element. Okay, you can see 1 is added with 41, it becomes 42. Then 2 with 42, it becomes 44. So 3 with 34, 37, then 48, then 147 to like this. So every element is added with respective elements in this array. And one more important thing is, whenever you want to perform these arithmetic operations, the shape of this particular two arrays should be exactly same. By chance if it is not same, then obviously you'll be getting an error. Let me show you. Let's assume that this particular array is having a different shape and the shape is not same. Then what happens is, for example, your a is this and b is this, and if you just look at your a shape, it is 2 comma 4 and b shape is 3 comma 4. So your array is something like this. A is this particular array and b is a particular array. So both arrays are not matching. Then what happens is, if you try to do arithmetic operations, obviously it doesn't work. It says operands could not broadcast between shapes 3 2 comma 4 and 3 comma 4. So when you want to perform any arithmetic operations, the arrays shapes should be matching. Okay, that's very important point. Okay, so now let me get back this. Okay, cool. So now it works. In the same way, not only the addition, you can do all the other kinds of operations. Maybe if you want to subtract, you can do like this. If you want to multiply, you can do like this. So for multiplication, you can also do like this. For example, let's assume that, first let me show with two arrays, then I'll show with one more way. Then if you want to find out the power, you can say like this. If you want to divide, so what happens in power? So it will do like this, maybe something like this. 1 power 41, 1 power 41, 1 power 41 is obviously 41. Then 2 power 42, something like that. So it goes on finding out the power of a power b, one element with respect to other element, something like that. Next, a divide b. So it will divide every element of a with respect to b, like this. Okay, in this way you can perform arithmetic operations. Here we perform the arithmetic operations with two arrays. We can also do with more than two arrays, and also we can do like this. For example, this is your array. Let's assume that every element of array I want to add 1 plus 1. So I can do like this. I can do like this. Maybe I can say like this: a plus 1. So what happens is, every element of array will be added with 1. You can see 1 plus 1 is 2, then 3, whatever you want to add. For example, if you want to 100, add 100 to every element of 1 for this particular array, you can see for every element you can do like this. So what happens is, for every element of array, this 100 is added. Okay, and if you want to then update it, you can update like this: a is equal to a plus 100. What happens is, every element of this particular array will be updated with this. Not only addition, you can also do power. Maybe power you can do like this. So every element will be powered with 100. Or maybe if you want to perform maybe something like division. So like this, you can perform whatever ways you want to perform your manipulations. Okay, depending upon your requirement. Okay, so that's how you can work with arithmetic operations in Numpy array. Next, now let's do in a slightly different way, some more operations in slightly different way. Yeah, so let's assume that this is your array back again. So I'm just taking this array like this. As usual, this is my array right now. So let me get this here. Okay, and the b also I'll get it here. Now here we have two arrays as usual, the same arrays whatever I've just created. Now I want to concat these two arrays, means I want to join these two arrays into one array. We can also do that by using concat operation. Here in concat operation, we have two ways of concating. Let's see that. Okay, so first thing, I'll just say np.concat of a comma b. So when I say np.concat of a comma b, what happens is, this particular array will be concating with this particular array. So you can see right now, whenever I say np.concat of a comma b, you can see 1 2 3 4 we have this one, and exactly below that you're getting this. So clearly what's happening here is, it is happening the row wise concatenation. It's a row wise operation. You can see why it is row wise operation, because I told you already, axis 0 means what? Row, right? We discussed about it already. So here in the concatenation operation, in this particular function, we have an attribute called as axis 0. So by default it is axis 0. So when you mention it is axis 0, means what? It will concat row wise but not column wise. Okay, so it will concat row wise. But I don't want like this. I want to concat column wise, means I want to concat like this, column wise. In that case, you should give axis is equal to 1. If you give axis is equal to 1, it will concat column wise. Right now, by default, it is concating row wise, means it is joining row wise. Okay. So if you want to update a new, I want to take this in a new variable, then you can say like this: C is equal to np.concat of a comma b. So in the C, you'll be having the output of concatenation of a and b. Very good. Now, for example, I want to concat column wise. If you want to concat column wise, you can mention just axis equal to 1. If you mention axis equal to 1, it will go with column wise operation. In column wise operation, what happens is, you can see it is concating column wise. You can see 1, 2, 3, 4. Then we are getting 41, 42, 43, 43, sorry, 41, 42, 34, so and so. And here we are getting this. So in this way, either row wise or column wise concatenation should be done. Now, one more important thing is, when you are doing the concatenation, guys, this number of elements should also match. Let me show a small example here to understand that. Let's assume that again we are having arrays like this. Okay, arrays like this. And when you're concatenating like this, it's very good. But by chance, if I have only, let's assume that here I'm having two elements in your, two elements in a two-dimensional array, means this one. But here we have only one element. Now, do you think that can we concat this by column wise? No. Can we concat this by row wise? Yes, we can concat, because yeah, we can also we cannot concat by row wise also, because here we are having only 3 elements. Okay, let me add one more element here. 45 I'll be adding. Yeah. So now I can concat by row wise. Row wise I can concat. If I say axis equal to 0, you can see row wise concatenation is possible. You can see. So 1, 2, 3, 4, 13, 23 and 41, 42, 34, 45. Yes. By chance, if one of the element is not present here, 45 is not present, can I concat this by row wise? It is clearly not possible. Why? Because here I'm having 4 columns, but here I'm having only 3 columns. So if I add a row here, these columns are not matching. So obviously, if I say np.concat, if I do a row wise, you can see it is not, the concatenation axis doesn't match us, because you can see here I'm having 3 columns, but here I'm having 4 columns, right? But if I add an extra column here, then it works as usual. So you can see one row, here I'm having 2 rows, here I'm having 1 row. I'm doing a row wise operation. So to these 2 rows, I'm adding one more row. That's okay. But column should match, right? Obviously. If columns are not matching, it doesn't work. In the same way, it goes for columns also. The same way goes for column wise operation also. If the number of columns, if the number of rows are matching, here I'm having 2 rows, here also I'm having 2 rows, even the number of columns are not matching here. So here I'm having 4 columns, here I'm having only 3 columns. Even the number of columns are not matching. If I do column wise operation, it works, because when you're doing column wise operations, the number of columns is not needed. The number of rows is important. So here I should have 2 rows, and here I should have 2 rows. It should match with this. By chance, if one row is missing here, if by chance one row is missing here, can I add this column wise? Just imagine. No, obviously no, because here first column is this. Okay, can I add column wise? No, because first row is this. I don't have another row, because it has 2 rows and it has only 1 row. So column wise operation is not possible here. You can see. So always we should maintain this important point. Okay. So when you're doing a row wise operation, the number of columns should match. When you're doing column wise operation, number of rows should match. That is very important when you're working, because of this reason. Okay, when you're doing the concatenation. Okay, perfect. Then this is how the concatenation works, either row wise or column wise. Next, we have something called as transpose of a matrix. We have something called as a transpose of a matrix. So what is transpose of a matrix? It's very simple. If you want to convert your rows into columns and columns into rows, you can use transpose. For example, let's assume this is your array. A is nothing but your array. If I say A dot capital T, it becomes, you can see columns has been changed to rows, rows to columns. So converting rows to columns and columns to rows is nothing but transpose. You can use A dot T, or you can also use NP dot transpose. You can use NP dot transpose and it also does the same thing, same way. Okay, these are how transpose works. So in this way, guys, I guess most of the Numpy functions, the basic Numpy functions we have discussed. I guess this is the end of Numpy right now. Of course, there are many other functions also. We'll be discussing that once we start our statistics and once we implement statistics. Most of the statistical functions we'll be discussing in our statistics session. But what I can do is, actually I can give a cheat sheet for you. Okay, just go to Google and just search for NumPy cheat sheet PDF. Okay, there is a very good link here, very first link, that is from by Datacamp. By Datacamp you'll be getting one link here, that is cheat sheet by NumPy. If you just go to this particular link, you'll be getting a cheat sheet where it's especially for data science, because we are learning NumPy for data science, right? So all the major important functions which we need for data science will be present here in this particular cheat sheet. You can just have a look and just see how this works. This is a very good cheat sheet made by Datacamp website. Okay, just let's go to this particular cheat sheet and see what happens, what we have in this. Okay. So first thing, it is talking about NumPy, what exactly is NumPy, and it's talking about arrays. You can see this one dimension, which two dimension means it will be having two axes. Three dimensions means we'll having three axes, axis 0, axis 1, and axis 2, as usual. And we have seen how to create an arrays. As usual, we have seen already how to create an arrays like this. Then we talked about zeros functions, ones functions. Then we talked about arrange function. We talked about linspace function. You can explore this full. We talked about random empty function, you can see. Then there is a one more operations here, how to save and load an array, NumPy array. You can take this as a task and try to explore this. It's very simple. You can just follow this. You can get this, how to save and load a NumPy array. Means, for example, right now you have a NumPy array like this A, and I want to save this. So you can use a simple function here. There's a function called as np.save, and if I say like this, np.save of so and so, what happens is and this is your array, whichever array you want to save, that is your value, np.save, and the name of array you want to save. So if I save like this, what happens is, in my existing file directory, you can see here, in my existing file directory, a file called as my array will be saved, and it will be in the form of .npy. .npy means .numpy array format. Okay. So what happens? So why we need this first thing? Why we need to save the array? So why we need to save the array means, let's assume that you have used a lot of manipulations. Let us assume you have an array, and we have done a lot of manipulations in that particular array. You have done multiple manipulations in that particular array. Now you want to share that particular array to your friend or a colleague, or you want to use that array in other code, and you don't want to again do all the manipulations in that particular code. Then what you can do, you can save the array here and load it in a different code. So let me show you how to load also. Here we have saved it, right? If you want to load in a different code, okay, so I'll do one thing. I'll just take a new code. Okay, I'm not doing any manipulations, or I'm not creating an array here, but I'll just load the existing saved code right now. So I'm taking a new Jupyter notebook, and as usual, I'm importing my NumPy. Okay, so I'll just say NumPy as np. As usual, I'm importing the NumPy. And if I want to load my array, I can simply say np dot load as usual. So here itself, we have a function called as load, so we can use load. And the file name, what is my file name? My file name is myarray.npy, right? So I'll just copy this and paste it here. And you can see, even though I have not created array, whatever array I have created in the previous code, that is present here. That is the main use of saving and loading my array. By default, if you just open this npy function, you cannot open that. Means it will be like this. Your editor cannot open this. But if you want to see this, you have to load it in a other function and load it. Now you can do like this. You can save in a variable and use it for your. So what happens is, when you want to save, you want to share your array to your colleague or someone, or you want to use it in a different code, you can use the saving and loading operation. So save like this, whatever array you are having, this particular array, and load like this. Okay. And if you want to save it as a text file also, you can do. So you can, if you want to save it as a text file, you can save here, save text, and use it. So like this, you can do all the other operations also. Then we have discussed about D types already. Int 64, float 32, complex, you can explore boolean, object, string. So object is nothing but if you have a strings basically, and sometimes when you have a combination of multiple data sets like collections, we have seen combination of lists, there only will be getting object. Okay. Next we discussed about few functions which can inspect your array, like shape, length of array, number of dimensions, the size, the number of elements, that is D type. The as type function, what it does, we have seen already. If you want to convert a shape, or convert a data type of one data type to other data type, array of one data type to other data type, you can use as type. Then we have seen few mathematical arithmetic operations like addition, subtraction, division. Then we have seen few functions Then we have seen comparison operators. Yes, yeah, comparison operators we have not seen, but let me show you. Very simple that is. Let's assume that you're having two array like this. Um, Something like this. If you want to compare these two arrays, you can do this. I mean, we have seen comparison operators using this. I mean, normal, we're just finding out less than whether or what are the elements less than two, like in Boolean indexing. But if you want to compare two arrays, we can do like this. For example, if I say A equal to B, it tells us whether any element matches. You can see none of the element matches, but the result says false. By chance, if I put here 1 year, okay, now you can see that the first element of A matches with the first element of B, right? So now if we say A equal to B, you will be getting C, you will be getting true because these two elements matches and remaining other elements doesn't matches. So you can do this for comparisons also, multiple array comparison and Boolean indexing. Then we have seen these all functions, guys. There are a few functions like sum, minimum, maximum. These all functions we'll be discussing in statistics. These are all statistical functions we'll discuss in statistics. Then we also have a function called as copy. I'm not discuss copy function here because we already discussed copy function in list. The same things works here. And we can also sort your array. You can explore this sorting. And then we have seen how to slice an array different way. So slicing arrays in different way, subsetting, slicing, Boolean indexing we have talked about. We can explore for fancy indexing. Some manipulations like transpose, we have seen that. Ravel and flatten is exactly same. What flatten does, it will create a what we call it will convert a multi-dimension to single dimension. It will flatten the array, right? The same thing Ravel does. We have seen reshape. Resize is almost same as reshape. Append function we discussed, insert function we discussed, delete function we discussed, concat function we discussed. You can explore this. V stack, H stack, vertical stack and horizontal stack you can explore, column stack you can explore. So like this, we have discussed most of the functions in this particular cheat sheet. Whichever function we have not discussed, you can just have a look into that particular cheat sheet and explore that. Okay. So the cheat sheet will be like a Andy for you. You can keep this Andy to explore about NumPy. So in this way, we are done with NumPy library. Okay. Thank you guys.